Well, good afternoon and welcome. We're recording today's webinar so you can view this at your leisure. My name is Robert Romanowski. I'm the Director of Sales Operations for 3HTI, and leading the overview and demo of Creo Flow Analysis is Andrea Francis, who is an Associate Solutions Consultant and Applications Engineer with PTC's Virtual Center of Excellence. So aside from keeping all of your hands and feet inside the ride while it is moving, we hope you have a cup of coffee or a good beverage to learn a little bit more about what Creo Flow does. This is one of my favorite extensions in the Creo suite. So I hope you have as much fun as I will. And if you have any questions, please type those in and we'll try to answer them as we go along, but we will definitely answer all questions at the end. Without further ado, Andrea, take it away.
Thanks, Rob.
Thank
And
you.
welcome everybody. So like Rob said, no need for really big introductions on my part. I'm Andrea, I'm a solutions consultant at PTC. I will be walking through what Creo Flow is, kind of what we do inside of Creo with it, and just show you around and the tool and the different things that you can define in it. So just to begin, we'll talk a bit about CFD in general, how it's being used in the industry today, and why the need to do it inside of Creo. So if you're probably familiar with all of this, but if you're somebody that works with a variety of different products that need some sort of flow analysis, whether it's you want to compute uh, internal flow through something, whether it's with gases or with liquids, if you want to work around different solids that you have and understand, of course, the flow, the velocities, you want to understand maybe thermal aspects as well and how that is affecting the product. That's what you do with computational fluid dynamics. You are able to see all of that information, you're able to analyze the product, and then get feedback on it if you need to make improvements. Now, what we typically see today is to run these different types of analyses, many of our different customers utilize extensive third-party software. That doesn't mean that those softwares are bad or they won't do the job. They're great at what they do. They specialize in the analysis tools. But there's caveats to that in the sense of maybe only certain skilled people that are the analysts can use them. Or you have to get outside of your CAD system, and that just adds more steps inside of the process that maybe you want to try to avoid. It's really time consuming, especially when you have to take the model, prepare the model for analysis, because a lot of times those different third-party tools don't take the models as is from Creo or from any other CAD system. You got to put them in a specific format. You got to prepare the model by defeaturing and prepping that information, and then putting that into the software, running the analysis, setting it all up. And then if there are certain changes that need to happen, most of the time people tend to bring that information back to the engineers and communicate that so they can go and make the change, but it just adds to what they are looking to do as far as just different tasks, right? And many times as well, we see people relying on physical prototypes. When you want to have, let's say, a certain piping system, or maybe you have some electronics components, a fan or something, and you're running a quick simulation on it, many times people tend to recreate that with physical prototypes. And I mean, there's not too much to explain around here around if you're running different iterations, that means you need to make changes to the prototype. It could cause a lot of cost as far as the development process goes. It could be time consuming as well. And when you don't have that much budget, you want to, as much as possible, reduce the amount of time it takes for development. You still want to innovate as much as possible. That's when people rely on software more than typical physical prototypes. But that's where tools that are like Creo Flow Analysis or even other simulation tools inside of Creo come in. Now, just to focus on the CFD side of things, what this tool is exactly what CFD does. It's computational fluid dynamics right inside of Creo to simulate the fluid flow. And the goal with it is you take all of your CFD capabilities and we're able to put them all inside of Creo in your CAD environment. So you don't have to go to a third-party software to be able to do that or rely on physical prototypes. And what we've been able to do with this is we've partnered with a partner of ours called Cimerix. They specialize in CFD. They have different tools. We've brought their tool inside of Creo. It's now an extension called Creo Flow, and we'll go through the different capabilities of it. But the goal with having simulation in Creo is to make it a part of your design process. You're making analysis, and specifically CFD analysis in this case, part of your process as early on as possible to get your results back as quickly and as often as you can, so you can avoid rework, you can avoid any issues down the line, and to speed up your design process as you go. So the way that it works is it's a tool that was built for all engineers, meaning if you are Creo users, you're already familiar with how to use this because it's the same interface as Creo. We'll walk through kind of the tabs through it and the capabilities, but it's basically from the ribbon, it's a left to right capabilities. Do you define a project? Do you define the simulation domain, the material, the physics that's going to be involved? And then you run the simulation to get the results in post-process. So we're able to bring in not just specialists for them to be able to utilize Creo Flow, but also bring in the ability for a standard Creo user to be able to use that tool. And what we're doing here is we're combining both CAD and CFD, and we're unifying this design process as more of an analysis-driven design process. Because what you're working on inside of Creo is you're working on the Creo model. You don't have to defeature, you don't have to translate to a different file format. Don't need to do any of those steps that are usually required by third-party software. You are doing everything in Creo. And then as you run the analysis, if there is a tweak that you need to make, no matter how small or big it is, you can jump back into the Creo model, make the change, whether it's on an assembly, whether it's on a part, and then have the analysis update with the results, and then you'd be good to go. So you get a rapid turnaround as far as the simulation goes. And with the way that you define this, the system allows you to either set up the mesh yourself or you can have the system generated for you. So even if you don't necessarily know how to overly define the mesh and go and do that manually, let the system do that for you. You can always tweak it if you need to, like if you have areas where you want to refine the mesh or you want to lightweight on it, you can go and still refine that yourself, but let the system do all of that complex work for you. And it does that based on the geometry that you have. So it will take all of your curves, it will take all of the complex surfaces that you have and generate meshes according to that geometry. And then it will actually create simpler meshing elements on the simpler type of geometry that you have. So it's already optimizing for what you have inside of a Creo and the types of models that you have. And then for the analysis is really quick. We found through different data that we've collected with Cimerix that this tool actually is quicker than a lot of different tools out there for CFD. You don't have to wait days or multiple hours for the simulation to give you results. It's actually a matter of seconds and minutes for you to get that information, and the results are highly accurate. So you have different ways to view the results as far as section views, different plots, if you want to view isosurfaces, and you can get that information in a way that isn't just a large sum of data like in an Excel sheet. You can actually get that visually on the model, which is always great. Let's jump into the demo now and see at a high level how it really works. So we're going to take a simple example with heat exchanger, and we're going to be just going about how to define the setup of Creo Flow, how we are we gonna predict all of that information, maybe the materials, even the different modules that we have, the meshing, and then running the different results and working in the Creo environment. So just to kick things off, as I've said, this is a heat exchanger. I've suppressed a few different features that we have, but just to show you on the outside, on the inside of that heat exchanger, it's completely empty. I don't have a lot of complex geometry, so we have a simple route from the inlet piping to the outlet pipe, and we're gonna see just the flow of our fluid go into that heat exchanger. So our gas in this case going into that to see uh, just the velocity of it, the routes of it, where it's going, the temperatures and the pressures at the end and what it outputs. And then if we take the case where this is maybe a legacy part that we're working on, or even just a new part that we are working on, maybe we want to try to improve on it. So we want to go from the current state that we are at to a more optimized state. That's where we can utilize a Creo Flow, not just to validate results as far as, okay, this is my temperature, this is my pressure, this is my velocity, but also what can I do to improve on it? And this is what we're going to do. So let me just go back in and make sure we're suppressing all of that information for the view, and then go to the application. So when you get the Creo Flow license, basically in our applications tab inside of Creo, there's a Creo Flow app that you can go into, and it opens up a new tab inside of Creo, like any of the other tabs for modeling and for measurements and stuff. You get that new tab just specifically for Creo Flow. Now we're going to start a project from scratch. You can always have projects that you've previously run, open them up again and save them against the model and have those be stored, let's say in your PLM system like Windchill. But let's say we want to start from scratch. Nothing has been created yet for that. Now, the way that we're going to define all of this information is we're going to start by defining the domain of our fluid. Do we want to have an internal flow? Do we want to have an external flow, something flowing like on the outside of that heat exchanger? Do we want both? That always depends on, of course, the type of product that you have and the type of geometry that you have, but you have options as far as what it is that you want to define. And then you would select onto the surfaces that define that domain. So in my case, for my internal domain, I need to define the start and end of that contained space, which is basically selecting my surfaces and the geometry that I have onto the model. And I'm just selecting onto the Creo model itself. I am not like changing my model or working in a step file format or doing anything complex. I am doing regular Creo selection capabilities as far as the surfaces and the curves go. After we've selected our domain, now we want to select what is known as the difference between where our fluid domain is going to be and where our solid domain is. So our fluid is what is the fluid that we have. In my case, it's going to be gas, or if it's just a liquid, that's also fine. And then the solid, what is the solid geometry that we need to take into account for the simulation? That could be one part, that could be multiple parts if we're working in an assembly type of model. That's where you start defining that. And then what are the materials, of course, associated to that? So in my case, we have the internal domain defined from the inlet pipe to the outlet pipe. And then it's going to take into account that solid and then all of the connections where it's basically hollow and shelled out on the inside. It's going to treat that as the space that it's going to allow that gas to go through. And this is just a simple setup. This is where we also go in and define the type of material that it is we're going to utilize. So what is the type of gas that we're going to have? We can have multiples. Those are all materials you can have managed inside of the libraries, inside of Creo. The solids as well, depending on kind of the properties that you have for your models, you can bring those in. And then on the types of physics. There's different physics you can have run through the analysis inside of Creo Flow. And that depends on what it is exactly that you are looking to analyze for your models. Not everybody needs to analyze for radiation. Not everybody needs to analyze for cavitation. It's just depending on, of course, the type of model that you have. But just a simple case, let's say we want to do turbulence, heat, and then streamline. Those are more of the common type of analysis that we could do. but you basically select everything that you want to analyze for. You can have one thing you want to analyze for or multiple things, really depending on what you want to do. And then this is where it sorts. So we have in this tree, we have the domains. So you can see for my case, we have the heat exchanger. We have different conditions that we can have set for that heat exchanger as far as minimum and maximum temperatures. And once we analyze and run the simulation, those results that are going to pop up in those plots that you see over here. So those right now don't have any information because we haven't run the analysis yet, but as we run the analysis, we'll see those update live throughout. But for the conditions, as you go in and define the boundary conditions, everything is stored in that tree. As far as, let's say, we have our inlet, what are we defining at that inlet? We have volumetric flux that we're specifying. What is its value? Maybe do we have a velocity profile that is uniform? What is the heat that we're starting with? Do we have any release particles? What is their direction? And then do that out the outlet as well. Like, what are we expecting from the pressure? What do we know as far as those metrics go? So we can specify all of that information right inside of Creo. It's all through the definition of Creo Flow, right, of setting up the study. And then once you have those set up, you can let Creo generate the mesh. So this is an example of it taking in that geometry that we have defined and taking in the model with, of course, our domains and the boundaries that we have for our domains. It will show the results right here at the bottom once we have those, but this is an example of how the mesh could look like. And you can clearly see it's already optimized for the geometry of the model that I have. So for the simpler surfaces, we have a different element size for the mesh versus at our piping. We have different elements, and even at the edges of the rounds of the connection between the piping and the surfacing, we have different meshing. So it's already optimized for that without me needing to really do anything. And then once I'm ready, I could just run the simulation, and then you can see it immediately pop up my information. We can, as it's running, visualize the results of how is it looking as far as the pressure is going in, as far as the temperature is going in. We can take a look at the streamlines, which we are really interested in this case with the simulation, and then gauge on, is this where I want this, let's say, this gas to flow in my heat exchanger? Would I consider different ways to route this so it maybe dissipates more heat, or it has a more uniform temperature distribution through it? It's just a matter of what are my goals with it and my design constraints for it. But I can clearly see from here live the animations. We see the temperatures. There's a legend that we see as well. Let's say this is the pressure. Looks good as far as the pressure goes. Maybe a bit high as far as what we are looking to meet for a simulation, but it's fine. Like for an initial simulation that we are running, at least we have a gauge on where it is that we're starting with. For the temperature, we can take a look at the temperature. We can see section views as well. You can create different section views in any direction that is necessary for you and have it dynamically update throughout the model, so you can see at different points in time throughout a certain section in a direction how that temperature distribution is looking like. From an ISO surface perspective as well, if we are interested, let's say, in once again, say temperature, and we want to analyze for that and see the surface and where those high areas and low areas are, we can actually flag those and see them in real time onto the model inside of Creo. Now, this is just a simple way of analyzing. We've just run the analysis. We quickly were able, in a matter of a few seconds, get those results. And traditionally, the way that it works is, of course, our analyst runs the simulation. Whether it meets our conditions or not is one thing to consider, but most of the time, there's changes that tend to happen. And a lot of times those changes is the analyst trying to make that change in the analysis or the third-party tool and trying to make minor changes onto the model so they can rerun the analysis multiple times without having to go back and forth too much with their engineers. A lot of times too, if it's a bigger change they can't really make on a neutral file format, they have to go back to the engineer, have them make the change, come back and rerun and another analysis with all of the setup in place. So that takes a lot of time depending on how much back and forth, how big the change is, and how good your communication is with your engineer. But inside of Creo, you can avoid all of that. You can go into the model. In my case, I have certain features suppressed, so we're going to unsuppress them and do that as if we made a change. So what we're going to do is we're going to add geometry on the inside, so this is not completely shelled out. In my case, I'm adding latticing capability, lattice geometry, which is an ability we have in Creo with our additive manufacturing extension. It's a great way for you to add in geometry that is lightweight, so you're not fully adding a solid body inside of the model. You're adding lightweight features, but those are going to add turbulence for our heat exchanger in this case. So they're going to help us dissipate the heat a bit more, have more turbulence in the case of where our gas is going to flow, and just improve the overall performance of this model. You can use latticing in a variety of different ways, whether it's in CFD or from a structural perspective, if you want to add more strength to your products without necessarily just doing blocks of geometry and solids. Those are great ways without having to add too much material into the model. So we simulated that. I am the analyst or the engineer can simply just go in, make that change inside of Creo. And something nice about this is if I already have a simulation study already run, I can just go back in, open it like what I just did, and then say update. And then what happens is it updates everything based on the geometry that I have. Now, I might need to add in additional things. Maybe if we added new geometry, we just need to add in those geometry in the consideration of the analysis. But it's just a simple matter of just adding in the selection of surfaces. And then what I would do is everything is already set up. So I would just let it run again, and then it will simulate everything for me again. All of my results are still present in my tree, so I can navigate between isosurfaces, section views, streamlines, like what we're seeing right here. And then we clearly see there's a difference now in the temperature that we are even gauging at. We started with a really high temperature to start with. Now, even the flow on the inside of that heat exchanger is completely different. We can see much more dissipation of heat, much more turbulence on the inside, a bit of a lower pressure than what we started with. So we can clearly see those differences. And this is just one of the simple ways we can utilize Creo Flow with Creo. Whether you utilize normal Creo capabilities, whether you have additional extensions that you utilize, like what I showed with the latticing and additive manufacturing. If you have other tools as well, like behavioral modeling, which you want to set a goal for a study and let it run a simulation and optimize the model for you, there's different ways you can utilize it, but this is a great tool to at least get you kickstarted on the journey of simulation-driven design versus just working with your analysts between a CAD tool and a third-party tool. I don't see any questions in the chat. Am I missing anything,
No
Rob?
questions. You are very thorough.
Great. That's always good to hear.
Yeah,
Okay.
very easy to understand too.
Yep. I guess I'll switch back then and just walk through my final slide here. So this was brief. I know this was a very brief introduction to Creo Flow, but I hope it was helpful at least make you understand what the tool does. But if we want to think about where the benefits lie into shifting your CFD work and process from a completely different tool to Creo, we have found throughout the work with our different customers, different key benefits. First, what I've talked about is the shift to a more analysis-driven design approach. Because when you shift to that, you're running analysis as early on as possible in your design process. And that helps to, first of all, help shape new ideas as early on as possible. Because you might find quickly in the process that maybe a certain idea or a certain geometry that you created works fine, but is it the most optimized? Not really. You want to try to get as much optimization as you can as early on in the process. So you just speed up that entire process itself. Most of the time is you want to be as fast as possible, reduce your costs, whether it's cost of different softwares that you use, because if you probably shift it to Creo and add the extension, it's probably cheaper than buying an entirely new license of a new software. That's one thing. Second thing, iterations. You can do multiple different iterations without needing any prototypes, without needing to necessarily go back and forth a lot. You're just working inside of Creo. And then you're overall just speeding up your time to market. So you're speeding up the development process, you're speeding up your validation process, and then at the end of it, you're still meeting quality standards. So you're not compromising on any of the quality of the products that you have, you're actually improving on it. Because if you add analysis earlier on in the process, you catch errors and you catch just the lack of optimization much more early in the process. And you can innovate. So you can, instead of spending time going back and forth, you actually spend the time on making the product much more differentiated from previous products that you've put out onto the market or against your competitors as well, because you have the time now to try new things, to test them out, and to get the validation from the tools right then and then as you're trying them out. So that's really the benefit of doing all of that inside of Creo. Great. I think that's it as far as a presentation that I have. Rob, anything from your end?
Excellent. I am right now a little challenged. I'm trying to, there's something that I want to share. Here it is.
Just stop sharing.
I'm
Might
going
be
to take
helpful.
control. I'm going to take control in a second.
Okay.
Having things are a little slow. Basically, what I want to do is I want to show the different packages with Creo Flow Analysis.
Yep.
As soon as, there we go. I can pull this up. And this looks lovely. And I get what percentage? Allow multiple presenters to share. Now, can you stop sharing for a second?
Yep. There you
One. I'm sorry about the delay,
go.
but what I basically just wanted to do real quick was, Andrea, can you see my screen with Creo Flow Analysis?
It's still loading for me.
Oh,
Just
okay.
Yep. Might be slow from my side. Not sure if everybody else can see it, but
And it tells me that I'm sharing,
oh,
but
there we go. Can
it
see
may
it.
still be loading. Okay, so there's other, there's other CFD tools, and part of the challenges with those CFD tools with their expense, like it's basically one size fits all, so they're pretty pricey. And you might not need all those capabilities. And I think PTC was very smart to have 3 different packages available for Creo Flow Analysis based on what you need to accomplish, so that you're not paying for capabilities that you're not going to use. So if you have any questions regarding the pricing of Creo Flow Analysis, you want to talk a little bit more about a project that you're working on, where you would need Creo Flow or need some type of CFD analysis, respond to the email that I sent you regarding this webinar, and we can have a conversation to see what we can do to help you out, whether it's through simulation services or CFD services, or from getting Creo Flow software as well, and getting you guys the right package that you need. That also, what's important is for your people to adopt this. And I know that Andrea did a good job explaining that you're getting results in seconds, minutes, as opposed to like 20 minutes, half an hour, or whatever. The results are very fast on this to help designers and engineers, get more insight into what they're designing. But if they're not able to use it, then that's a problem. So we're big into our customers being able to adopt and use their PTC software. so that they can accomplish their goals. So with that, we're going to end the webinar, and I want to thank everybody for being on today. And Andrea, once again, you did a great job. And if you have any
Thank you.
questions or need anything, feel free to respond to the email that I sent you or contact us at info@3hti.com. Thanks, everyone.